Hallo, guten Morgen allen Schatz. My name is Dr. Doofenshmirtz. I'm here today so that we can repeat an experiment. Every experiment should be repeatable and peer reviewable. Correct? So we have gotten this experiment from I think I got it from Doc, Sneezy, Grumpy, Sleepy, that's it, Sleepy. We got this experiment from Sleepy. I think he calls himself Warrior. We all know he can't be a warrior. So we'll call him Sleepy the FOTY. Okay? So his last name, the FOTY. He has an experiment where he takes some water in glasses and puts an egg and adds salt to see if the egg might float. So our hypothesis would be, does an egg float in salt water? Yeah? Does an egg float in salt water? So we will try this. First of all, we get our measuring cup because we don't want to just put arbitrary amounts. We want to measure and be exact. That is a good experiment. So, one cup tap water, one cup tap water, one cup tap water. So now we have 3 glasses, 1 cup tap water. Measured 1 cup tap water. Measured. Now before we go on, we should do some background search. So I did a little background search and I find this kind of information, which of course we didn't see in Sleepy. Tap water has a density of 1 gram per cubic centimeter, which is the same as 1 gram per milliliter. Turns out that is the definition of density, 1 gram per milliliter. So then I checked a chicken egg you know, bark, 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 bark. Chicken egg, chicken, chicken, chicken egg. The density for that, 1.031. 0.031. So it is bigger than tap water. And then the last one I looked up was salt water. The salt water will vary based on how much salt you put in it. But basically, it is 1.0273. 1.0273 tap or salt water. So we've done some research, and we got some numbers. So in just plain old tap water, we can see, we put the egg in, put the egg in the tap water and put it all up. So here we go, egg in tap water. You can see, can you see? Oh, say, can you see? The egg sinks to the bottom. So it is on the bottom of the glass. Now, we are going to add salt. That's what the experiment is. Our hypothesis is, can a chicken egg float in water? So here I have a measuring cup. That line in the middle is 5 milliliters, which is what we'll add each time. Okay, add that. Okay. Add that. And stir it all up. So just like in the experiment, we have to add energy in order to have the salt water dissolve. So here we are. I used a different stirrer for this one. And you can see 5 milliliters doesn't make any difference. It doesn't float. So let's try 5 more. Yes, 5 more. 5 more. 5 more. Okay. So we have 5 more. stir it real good. Remember that all experiments must be easy to see results without question. You can be sure that I didn't do anything. I promise I didn't do anything. You saw me add the water. You saw me add the egg. And now we stir. So now we have 10. Yes, 10 milliliters. And nothing. Nothing is floating. We need to stir a little more. Have to add more energy to get the salt to dissolve. Add more energy. Add more energy to get the salt to dissolve. Okay. So now we have 2 5 milliliters, which is 10. We have 10 milliliters. So now we add 5 more, which is 15 milliliters. See? 5 milliliters. That was too much. Okay, 5 milliliters. So this makes 15. Still, no floating. I've got my stirrers mixed up. Must add energy or the eggs will just stay on the bottom because you need to dissolve. So let's see. Oh, they're not floating, but they've kind of moved up a little. So we'll try one more. That was 15. Try 20. Ooh. Sometimes salt has a mind of its own. So we have 5 milliliters. Put in there. 5 more milliliters. 5 more milliliters. Okay. So now we stir again. Add some energy. So now we added energy to both. Oh my, this one is floating. I don't know if you can see that. It is floating and touching the top. So let's add a little more to this one. Go. Oh, did you see that? It came up and then went back down. Must mean it's very close. Very, very close. So now they are both floating the same amount. And the reason I probably had to add more to this one is because my measurements were a little off. Like I said, you know, salt kind of has a mind of its own. So we want to add a little more to this one, just this one, and see what happens. Okay, so we add a little more. It's a little bit higher than this one. Let's do one more, just for one more. Just one more. Since we're doing it. And we stir, add some energy, add the energy, and we see not much change. So I think we've pretty much met our criteria here. Let me wash my hands. So, egg floats in salt water. Little bit with 20 milliliters, a lot more with 30 milliliters. So we're seeing that the amount of salt means that it floats more. Salt is our controller. Our salt is our independent variable because it's the one that I controlled. So the salt is what made the egg float, and it is the density of the water, because we've changed the density, and the egg comes up. Okay, so I have an explanation. We're going to do some some analysis. That's what we're going to do, analysis. So here we have a graph showing that the more salt we put in, the density changes. Rho equals density, and height changes. Height is the independent variable. Okay? So, let's recap just a little bit. What have we learned? We have learned that you start with tap water. Oh, we love tap water. You put the tap water in, and you carefully put the egg in the water. Put the egg in the water, and then it will float. So we put the egg in. We add the salt according to very specific measurements. Okay, very specific measurements. And then we find that 20 milligrams of salt makes it float barely to the top of the water. 30 milligrams of salt makes it float a little bit higher. Why is that? Why do you suppose that is? Let me assure you, according to Mr. Sleepy FOTY, it was not me that made the egg float. It was not me. I did something to the water, so I was like a catalyst. I didn't change. I added to the water. I added kinetic energy, and the egg floated. Now, I went again to look up some information, and I find, of course, we all know gravity. The force of gravity is found by this equation, which is F equals M times G. That's G. So, again, unlike Sleepy FOTY says, scientists do most certainly use mass in computations and in experiments. Okay? Now gravity, you can see gravity has a plus. It's positive. That means that gravity pulls down. Gravity only pulls down. Gravity cannot make things go up. Gravity is a force that makes things go down. The equation there is a positive number, which means it goes down toward the center of the earth. Now, buoyancy, on the other hand, which is what we experience today, buoyancy we had the force of buoyancy is equal to rho, is equal to minus rho times V times G, which is the same G, acceleration of gravity, due to gravity. Now the interesting thing that you have to look at is that this rho times V, that's density times volume of the fluid, density of the fluid, that gives us what? Buoyancy is this force of B, which stands for buoyancy. That's why we call it B. Be silly to call it something else. F of B, buoyancy, is minus rho, which is density. Rho is density times volume. So this is rho, which is density of the fluid, the water, and V is the volume of the water. So and then times G, which is the same G as up here, same G. Okay? Now, what is rho times V? Anybody know? Anybody? Any of you know what rho times V is? Rho is density. V is volume. You multiply those two together and you get mass. The mass of the liquid. Amazing, amazing, amazing. Mass times the density. Mass times the acceleration due to gravity. Now you notice that buoyancy has a negative. That's because buoyancy is an up-only force. It goes up, 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 up only. Only up, not down. So we only go up with buoyancy. That's why the equation is negative. Now, I wanted them to call this the Duffin-Smertzenkopf equation, but for some reason physicists didn't want to use that. So we call it the Archimedes principle. And you can look it up anywhere and you will find the same thing. So what have we learned? We learned something very powerful here. We learned that the force due to gravity is mass times G. We learned that the force due to buoyancy is minus mass times G. So they're very closely related, and that's why Mr. Sleepy FOTY got it all confused because he didn't understand. So that's the experiment and the analysis. You see that we've done both. And so I have a couple more things I will post in the description. Some homework so that you can go look at it. Give me your thoughts on how Duffin-Smertzenkopf experiment compares, and we'll see you next week. Also, I have one more question that goes along with our experiment. Think a minute, you'll have to think about it. Can we make the egg sink? How would we make those eggs sink? Can you make them sink? Go back down to the bottom. Can we do that? So let's put on our thinking hats and think about it. Can we make those sink? Can we make those sink? Boy, that's a toughie. So I'm going to give you that for homework. You need to go this week, study that for homework, and see if you can decide, is there a way to make the eggs sink? Should I give you a clue? I'll give you a little clue. It can't be done. The eggs won't ever sink. So, that's all for class today, students. We will see you when we see you. And I know Turbo Brain will be back next week.